Cauchy's mean value theorem. The statement says if f and g are defined on closed interval a comma b such that f and g are continuous on closed interval ab, f and g are derivable on open interval ab. G dash of x is not equals to 0 for all x belongs to a comma b. Then there exists c belongs to ab such that f dash of c by g dash of c equals to f of b minus f of a by g of b minus g of a. This is the statement of the Cauchy's mean value theorem. Cauchy's mean value theorem is also known as generalized mean value theorem. Now moving on to the proof of this theorem, they already told if these three conditions satisfy, then we can tell that f and g are defined on closed interval ab. So we'll just take a function phi is mapping from a comma b to r. I'm just taking a function phi from a comma b to r such that I'm defining this function in such a way that phi of x is equals to f of x plus k into g of x. Let this be equation 1. How am I defining phi of x? F of x plus k into g of x, where k is a constant function. And let us choose phi of a is equals to phi of b. And we already know that, what is that we know? This f of x, k and g of x are continuous functions. F of x, comma k, comma g of x are continuous functions on closed interval a comma b. As it is continuous function, obviously this will be derivable. So and it is derivable on open interval a comma b. We got it is continuous. This f of x, k and g of x are continuous. Where are f of x plus k and g of x? This phi of x. So we can tell that the entire phi of x is also a continuous function. Phi of x is continuous function on closed interval a comma b. Why did we get phi of x as continuous? Because we already have this f of x, k and g of x are continuous. Where are all these functions? They are in phi of x. So phi of x is a continuous function on closed interval ab, and it is also derivable. As it is continuous, it is also derivable on open interval a comma b. Am I clear till here? As it is continuous and derivable from Rolle's mean value theorem, we can tell that we know that phi of a is equals to phi of b. So that is phi satisfies. What is that we had? We showed it is continuous, it is derivable, and phi of a is also equals to phi of b. So all these three conditions satisfies Rolle's theorem. So we can clearly tell that this function phi satisfies all the conditions of Rolle's theorem. All the conditions of Rolle's theorem. Now, what is Rolle's theorem? Third condition says if it satisfies all the three conditions, then there exists a C belongs to A comma B such that this phi dash of C is equals to 0. What is phi dash of C? Like what did we take phi of x? Phi of x is equals to some f of x plus k into g of x. Okay. This we took previously. So this phi dash of c equals to 0. So we can take that as f dash of c plus k into g dash of c is equals to 0. Now from this we can find f dash of c. F dash of c is equals to minus k into g dash of c. Okay. So what is f dash of c by g dash of c? Is equals to minus k. Let this be relation 2. Now we got f dash of c by g dash of c is equals to minus k. We know that what is that we took? we know that phi of A is equals to phi of B. This implies, as we have already seen earlier, what is phi of x? Phi of x is equals to f of x plus k into g of x. So that is what we have to write here. What is phi of A? F of A plus f of A plus k into g of A. That is equals to f of B plus k into g of B. From here, you can find the value of k. Now, take k terms one side and f terms one side. What is that you'll get? You'll get k into g of A minus k into g of B is equals to f of B minus f of A. Take k common. If you take k common, what is that you'll have? G of A minus G of B, or take minus k common. If you take minus k common, you'll get G of B minus G of A is equals to f of B minus f of A. Now, what is minus k? Minus k is equals to f of B minus f of A by G of B minus G of A. What is what is minus k from equation 2? What is minus k? It is f dash of g by g dash of g. Okay. Now, let us just substitute that. So what is that? We had minus k is equals to f of B minus f of A by g of B minus g of A. Now substituting minus k, what is minus k? F dash of A by, f dash of C by g dash of C. That is equals to f of B minus f of A by g of B minus g of A. This is what we had to prove. Am I clear till here? Let us now look into another form of Cauchy's mean value theorem. This is another form of Cauchy's mean value theorem. Cauchy's mean value theorem. So in this other form, what is that it says is, if f is mapping from a comma a plus h to a real number r. If f is mapping from a comma a plus h to r, and g is mapping from a comma a plus h to r, such that the first condition is obviously f and g are continuous on closed interval a comma b. The second one is f and g are derivable on open interval. It is from a to a plus h. Sorry, it is not from a to b. It is from a comma a plus h. And f and g are